Yeah, with him. Yes, yes. All right. See, we were talking about what we spoke in the last class. We were talking about the effect of wind on the aircraft. So I hope you understood why headwind is reducing the range and why tailwind is increasing the range. Now you see, if I can stay lesser in the headwind, I can minimize the effect of headwind. And how will I stay lesser in the headwind? By flying faster. If I can fly instead of 80 knots, if I can make it 100 knots or 120 knots of true airspeed, now I'm flying faster. The wind is still 10 knots blowing towards me. I cannot decrease the speed of the wind, but I can increase the speed of the aircraft. I'm just getting out of the aircraft as quickly as possible, right? Therefore, one way to actually reduce the effect of headwind on the range is still going to reduce. But how much is it reducing? You can reduce the effect of headwind on the range by flying faster. Right? Makes sense? So when you fly faster, which means now you're flying at a velocity that is more than the minimum drag speed. You have to fly faster, there's no choice. If you fly at the normal VMD speed, you are now going to stay longer in the headwind, experience longer the effect of headwind, and therefore you're going to have a reduced range. Similarly, if you think about tailwind, you're flying at the tailwind is going to increase your range anyway. But we just don't want that. We have to take advantage of tailwind. We have got tailwind anyway. So how will you maximize the effect of tailwind? How can you use tailwind and increase the range even further?
By increasing flying faster on the edges.
No, that's the thing. See, when you fly faster, that's the problem. When you fly faster, it's a happy thing that you're flying faster, but your drag is going to increase equally because higher the velocity, higher is going to be a parasitic drag. And with this tailwind, you are going to fly faster, and that is going to create so much of a drag, parasitic drag on the aircraft, that your range is going to come down. When your parasitic drag increases, the range reduces because the total drag is going to go up. Therefore, since you have so much amount of a tailwind, you have to now fly slower. So what happens when you fly so slower is you are flying slower, which means that your parasitic drag is going to come down. At the same time, you are pushed by you're traveling in an air parcel that is going at, you have a tailwind basically, which means you're traveling in an air parcel which is moving in the direction of your aircraft itself. The aircraft is moving in that direction, the air parcel is also moving in that direction. So you're automatically, your range is increasing. But when you fly slower, your drag is also coming down, which means that is going to maximize the effect of tailwind and therefore increase the drag further, increase the range further. Right? So understand, headwind is going to reduce the range, tailwind is going to increase the range. And if you can fly lesser, fly like quicker or fly faster through headwind, you can minimize the effect of headwind. And if you fly slower through tailwind, then you can maximize the effect of tailwind. So flying slower, which means you will be having a speed that is less than the minimum drag speed. Understood? Makes sense? So don't think that when you fly faster, you can actually increase your range. No, when you fly, the aircraft is having a higher true air speed. What happens to drag? The drag is actually going to increase. The parasitic drag is going to increase with speed. Right? Do you understand the effect of wind on the range of the aircraft?
Yes.
Right? Now the third factor which affects the range is the altitude. Now regarding the altitude, the effect of altitude on the range, it practically depends upon the type of engine that we use. That's one of the major factors that altitude depends on, is the type of engine. Right? Let's look at question number 51 very quickly, and then we will move to question number 152, which is going to explain all these things again, and we will discuss it again. Question number 151, I think we have already discussed in the previous class. We can just go through it once again very quickly. To achieve maximum range, an aircraft must be flown at a speed that produces. Yes, Anuj.
Bravo, sir? No.
That's a minimum drag. Minimum drag is maximum range. Now there's a problem here. What if I fly at minimum drag speed in the headwind? Is that going to give me maximum range?
If you fly at minimum drag, no.
If I fly at minimum drag speed, that is not going to give me maximum range because the effect of headwind is going to reduce the drag. I have to fly faster
Faster.
Right? In the tailwind, if I fly at minimum drag speed, the tailwind is already pushing me forward, which means my speed is higher that my drag is going to be higher, and therefore my range will reduce. Therefore, I have to fly slower in the tailwind. Therefore, when you say that minimum drag is going to give you, so the VMD is going to give you minimum drag, or minimum drag is going to give you, minimum drag speed is going to give you maximum range, when is that possible? So blindly when you talk about it, that is possible only in nil wind conditions, not when you have headwind or tailwind. In case of headwind, tailwind, you have to change your speed and kind of manipulate your drag to get maximum range. Right? So this particular graph, that's why I've written here nil wind. You see, as the wind changes, this will not really work for a given weight. Right? Therefore, you can add a line there. To achieve maximum range, an aircraft must be flown at a speed that produces, in brackets you can write, in nil wind conditions, is minimum drag speed. Otherwise, you will have to fly at a higher drag. Remember, the minimum drag speed of the aircraft is still the same. It doesn't change. Only thing what changes is the velocity corresponding to that. Yes, so Bravo is the answer. What about minimum power? What is Charlie? What is minimum power going to give us? Minimum power will give you maximum endurance. Why? Because minimum power means minimum RPM. Minimum RPM means minimum amount of fuel taken per revolution, and therefore your fuel consumption is less. Therefore, you have for a given amount of fuel, you can stay longer in the air, and that is what is called as endurance. So with Charlie, it is talking about maximum endurance or maximum range. Right? What about least lift bar drag ratio? Yes, only in nil wind channel. Correct. That is your normal VMD. If you fly at normal VMD speed, it's going to be. No, you're talking about maximum endurance. It is independent. Endurance is independent of wind. Are you talking about endurance to me? That regarding the wind, which you just send me? No. The effect of wind on endurance is nil. There is no effect of wind on endurance. We will see that in the factors affecting endurance now. But option Charlie, minimum power is possible only if minimum power is going to give you maximum endurance. Doesn't matter what the wind is. Right? You might be staying up here for 2 hours, not moving an inch forward because of headwind. Your range is 0, but your endurance is still 2 hours because it's talking about how long you stay in the air, not how far you go. Right? We will see that. Now, what about delta? Least lift bar drag ratio. When you have minimum drag, what happens to lift bar drag? It increases because drag is the denominator. Minimum drag means best lift bar drag ratio or maximum lift bar drag ratio, right? Which happens at alpha is equal to 4 degrees, optimum angle of attack. We have seen that before, right? Now, question number 152. Yes, Anuj, read the question.
Okay. Which of the following statement on the effect of wind on range in level flight is not correct?
Yeah, effect of wind on range on level flight. That's what we're talking about here. Yes, first one.
Headwind increases the maximum range possible.
Yeah, is that correct? Headwind increases the maximum range possible.
I think no, sir.
No, therefore that is the answer. Your question is asking you to find out the statement which is not correct. So alpha is the answer, but as you know, the answer is not the one that is significant to us. We have other options which are relevant. Yes, next question, next option.
Next one is tailwind increases the maximum range possible. Yeah.
Tailwind increases the maximum range possible. Yes.
Nil wind, maximum range is attained at minimum drag speed.
VMD. When there is no wind, then you can have the maximum range at the VMD speed. If you have a headwind, you have to fly faster than VMD. If you are a tailwind, you have to fly slower than VMD. Right? That's correct. Yes.
Okay. In headwind, maximum range is attained at a speed greater than VMD.
Yeah. Why is that? When you fly faster, you stay lesser in the headwind.
Then what is V?
V is the speed at which you are flying. And that has to be more than the VMD speed. If there is no wind, you can fly, your V can be equal to VMD, therefore you get maximum range. But if you're on a headwind, I want to stay lesser in the headwind, which means I have to fly faster, and therefore V is going to be more than VMD. Right? So you can write a command, right, to minimize the effect of headwind. Option delta, or you can write option notebook, you can write option delta is minimize the effect of headwind. So you have to fly faster than VMD to minimize the effect of headwind. Is this clear to you? What we have written here? Why do you have to fly faster in the headwind and why do you have to fly slower in the tailwind to minimize and maximize the effects?
Yes.
Is that part clear? Yes. And what's the last one?
In tailwind, maximum range is attained at a speed less than VMD.
Less than VMD. Because if I fly faster now, the tailwind is also going to increase in speed. I am also flying faster. So net velocity will be so high that my drag is going to be higher. Because my parasitic drag increases with square of velocity. Right? And therefore, there's no big deal. Your range is going to come down because of drag. Right? Therefore, I have to fly slower because my range is still going to increase because the tailwind is going to push me anyway. Right? That is why we can put a comma and write to maximize the effect of tailwind. I have to fly slower to maximize the effect of tailwind.
Okay.
Alright, yes, I hope both of you cannot really talk. So again, the question is again for you 153. The answer to the previous question is alpha. Okay. Which of the following statements on the factors affecting range in level flight is not correct?
Alpha, increase in weight will decrease the maximum range for given angle of attack at higher VMD.
Increase in weight will decrease the maximum range for a given angle of attack at a higher VMD. Is it correct? So when you increase the weight, your lift induced drag increases. So we have seen that before. Let's see the graph again. Let's have a quick rewind of the graph. Drag and speed. Now the basic drags are the lift induced drag, which decreases with speed, and you have the parasitic drag, which increases with speed. This is the lift induced drag. This is the parasitic drag. And from this we have kind of found out the total drag curve, which is also the thrust required curve. Remember all these things? Right? This is the total drag. What is this? This is the point where the drag is minimum. And therefore, the speed is what is called as the minimum drag speed, which is going to give you maximum range, remember, in nil wind conditions. In headwind, tailwind, that's going to change. Right? Now what happens when you increase the weight? So basically when the weight increases, just give me a second. Yeah, basically as weight increases, what happens? What is the immediate requirement there when the weight increases?
Weight increases, range decreases.
Alright, lift required increases. Yes, so when lift required increases, you have to increase the lift somehow. You have to increase the angle of attack or increase the speed, lift equation. Some of those factors has to be actually increased, right? And now what happens when you increase the lift? The drag that proportionally is going to increase is the lift induced drag. That is actually going to increase, right? So the lift induced drag is actually going to increase. Now you see what happens, the lift induced drag increases, your parasitic drag is right there, and therefore you can see this is now the point where the both of them intersects, and therefore this is going to be the point where you have the minimum drag speed is going to be at a higher indicated airspeed. Now if you look at the total graph, you can see that since the lift induced drag increase, this portion of the graph is going to go up more, right? So it's going to go up in such a way that the minimum drag is going to happen at this particular point, and then it is going to increase. So will you understand why the increase is happening here and not much here? Because the lift induced drag is the one that increased. The first half of the total drag curve has gone up, right? And therefore you can see this is the new drag curve. So what happened when you increase the weight? Your minimum drag speed increase. Now this is your minimum drag. Now corresponding to that, this is your minimum drag. So what do you think? We know that minimum drag corresponds to maximum range. What happens to the minimum drag when it increases? This is the minimum you can attain. You cannot go anywhere below that, which means what happens to your range? Your range is going to reduce. Right? That is why we say with increase in weight, you can see that with increase in weight will decrease the maximum range for a given angle of attack at a higher VMD. You can see how the VMD is now at a higher indicated airspeed. We have seen this graph a lot of times before, so it's nothing unfamiliar to you, right? So what you can do is you can write option alpha and you can draw this graph.